So how do we make progress on this? Well, for the robot to do well on this problem, the robot has to find a way, I'm going to state the obvious, the robot has to find a way to actually estimate this internal state. And that means that it will have to look at human feedback, and it will have to observe that feedback or solicit it, and it would have to ask itself what this feedback, what these signals actually teach it about what the person wants. So it's an estimation problem, and ideally, in an idealized setting, you would actually maintain a full belief over data and then update it based on feedback as you observe it. And so crucially, this requires what in sort of Bayes filters would be called an observation model or likelihood function. So this requires, here's basically a human model. It's this thing in orange on the slide that tells you if this were the thing that the human would want, if this were the data, what feedback would you expect to see? Okay, so then what you can do with that is you can do a Bayes update. Now, I want you to notice that RLHF is basically an approximation of this. It's a version of this problem, right? Where in RLHF, you show people two options or more. And back in the day before LLMs, we were doing this for cars because cars needed reward functions and we didn't know how to specify reward functions. So we're trying to learn them from this kind of comparative feedback. So you give people two trajectories for an autonomous car and you would ask them, well, which one's better? And the observation model that we were using, that's the kind of the default in RLHF, is this kind of softmax model, right? It assumes that the person will be rational, will be approximately optimal with respect to what they want. So rational with some imperfection, noisy rational, the probability that they say on the bottom left there, the probability that they say A is proportional to the exponent of the reward of A. So if you come from an RL, you just sort of refer to this as a softmax thing, but as a human model, specifically, we think of it as a Boltzmann rational model, a Luce-Shepard model, something like that. So here's an example. On the left-hand side, you see the prior that we start with. And what you see there is sort of like the prior over different weights for different important features that a self-driving car might care about. And the right-hand side, you see a version of the posterior that the robot learns as it actually collects this kind of feedback from people. So it's starting to glean that, like, the purple thing is collision avoidance, important, and negative weight to get into collision, stuff like that. Now, why am I saying this and why I think it's a useful perspective to think about RLHF this way? Well, it teaches us a few things, this formulation. One perspective it gives us is that, look, there's not just comparisons out there. There's many types of feedback, right? Like you saw me push on the robot. That's a type of feedback. I can say, no, that's not what I really wanted. That's feedback. You should learn from that. I turned the robot off. That's feedback. It should learn from that. So there's many types of feedback. I will enact this video, okay? So we're back to my lab and we're back to the robot carrying the mug. And what happens in this video is the robot starts moving and I go and I push on it in the same way as in the beginning. But in this case, the robot interprets that correction as feedback about the reward function that it's optimizing. It runs and approximates a quick inference on this. So you have to do a bunch of work to figure out how to approximate this online. It updates with whatever reward function actually best explains this correction. And then when I let go, it actually starts moving and keeping the cup freaking closer to the table. And it's very satisfying. And it's so satisfying that as it does that, this was not staged or anything. I just instinctively give it a thumbs up. I'm like, okay, good, it's going. Which, by the way, a thumbs up is also very much feedback. But we have to be careful about this kind of feedback.
更多演讲实录与文章已收录至雷锋网ICML 2026深度专区，现已全面上线。专区不仅全面收录了重磅论文的工程化解读、专家前沿演讲，更将持续更新前方记者的第一手会议动态。扫描下方二维码，或进入雷锋网ICML专区即可查看。